Next speaker is Michael Chang. Michael is the Vice President and General Manager of Advantest Cloud Solutions, or ACSH, which is a strategic business unit within Advantest Corporation directed at helping customers accomplish intelligent data-driven workflows. Michael has 25 years of diverse experience leading product innovations and business growth across AI, machine learning, cloud data center, and semiconductor spaces. Before joining Advantest, Michael was the general manager of AI solutions business at Supermicro Computer. Prior to that, he was the co-founder of a deep learning startup. He has also held multiple leadership roles at several IC companies, including LSI, Marvell, and Vitesse. Michael holds an MBA from UC Berkeley, a bachelor's degree in electronics and communication engineering from the National Chiao Tung University, and has completed the executive leadership program from Stanford's Graduate School of Business. The title of his presentation today is "The Road to Chiplets is Paved with Data." So ladies and gentlemen, please help us to give a warm welcome to Michael.
Yeah, thanks, William. I'm sharing my screen. Can you guys see that?
Yes, very well.
All right, hey, thanks, William, and for your the introduction. And it's my pleasure and also my honor today to be able to share my views on the semiconductors testing in the era of the chip convergence. Just like William mentions there, right? I think, and also many of the speakers, including the Dr. Wu and also Frank just mentioned there that the semiconductor, just like many industry, is experiencing a data revolution. With more and more functions are carried on a chip, and the technology is more and more complex. Semiconductor manufacturers are packing more chiplet in a package. This product enables us to cram huge amount of components into a growing array of products, and all those components must be tested, and the corresponding amount of the test data will meet any reasonable definition of big data. So in this presentation today, I'll talk about that how industry leaders are actually leveraging the AI machine learning to do the gold mining on the semiconductor manufacturing, the big data, and how can they use that to deliver significant improvement in production yield, quality, and cost savings. I also talk about providing specific example of machine learning analytics solutions developed to solve the real industry problem. And also in the end, I also talk about that the Advantest is actually working with the industry to promote the open solution ecosystem to build the right data infrastructure and the application to enable the collaborations. So want to give a little bit background on the Advantest. So Advantest is a global leader basically in the AT space. The company has lead the way in developing new and innovative test solutions for the global electronics industry. The company is in the field in this automated test equipment for this with more than 40,000 systems installed worldwide. Those equipment are used in the semiconductor engineering and manufacturing environment to verify a silicon performs to its specification and make sure that it actually works in its end user application, which might be the consumer electronics, telecommunications, automobiles, medical instrument, cell phone computing, digital TV, to name a few. So the Advantest Cloud Solution is a newly formed business unit within Advantest with the charter focusing on provide the advanced insight for silicon manufacturing, testing, and system maintenance. So basically that the company has more than 5,000 employees from the more than 50 countries. And so the next one I want to give everybody some quick updates is talking about the little bit the trend on the semiconductor industry. So we've almost gone through the COVID-19 pandemic, and when we look ahead in the future actually looks pretty bright, almost blinding bright. Some of us, you know, that it took more than 40 years to get to the 200 billion revenue in the semiconductor markets. And then that double actually in 20 years. Now we see that the possibility of doubling again in a short of 10 years. After the mainframe days that put semiconductor on the map, we've now had the internet wave, which continues, using the silicons for networking, for computing, for AI, and then mobility, waves comes in, such as the smartphone, self-driving cars, and coming the virtual reality, the meta universe. But now we have this wave, someone called it the age of convergence, which is driven by AI that creates these virtuous compounding cycles of data. And it's not like these waves are coming and going. They are in phase, and they're going to produce this growth curve. So from the unmanned driving to virtual reality, from the artificial intelligence to cloud computing, from 5G to the IoT, many driving forces jointly promote the continuous advancement of the semiconductor manufacturing and the testing technology. With a huge demand of the electronics ever complexity, and in the face of the bending the curve of a Moore's law, semiconductor manufacturers are moving to a chiplet-based paradigm, as many of our speakers, was talking about using the chiplet to enable more complicated, SoC and the silicon development. And this part enables us to cram huge number of components into a growing array of products. So the traditional methods, right? I think for the traditional the manufacturing and the testing process are less and less suitable, and also becoming cost prohibitive to managing those data explosion. Let's take a look at the semiconductor test ecosystem. Huge amount of the data are generated and collected across the different stages of the manufacturing life cycle. Right? I mean, you can see the chart here from the post-silicon validation, wafer acceptance testing, wafer sort, all the way to the system level test in the right. Semiconductor manufacturers struggle to realize the value from the data they collect. Some of the key challenges that the vendors that they face today, including, for example, how to integrate all the data sources across the entire IC manufacturing supply chain, how to combine advanced analytics and the machine learning capabilities and enable real-time automated production control. So semiconductor test value chain it's a pretty complex and actually outgrown, from the point solutions lots of the the manufacturers and the vendors are using today. Over the past 20-30 years, right, we've been spending most of the time optimizing the testing efficiency at each insertion point. But now with the AI, high bandwidth networking, cost-effective storage, and advanced computing capacity, the industry has actually what it takes to do the gold mining on semiconductor data. But that's not enough. Actually, we also need infrastructure and a partnership in place to enable the supply chain to realize and extract the tremendous value from the big data. So the question here actually is that how do we do that, right? I think if we look at this today, right, the industry actually has done a pretty good job optimizing efficiency But actually, what we're seeing is that, because of the fragmented and distributed nature of our industry, a lot of those solutions were self-developed, isolated, and generally unscalable. The industry actually did a wonderful job, in the time, right? But some of those solutions that develop are quickly become obsolete, especially with the modern data centers and all the capabilities available. The more data actually is shared forward and backward, and up and down in the test ecosystem, the more valuable it can be. So we at Advantest actually has a responsibility to the industry, as it is our system that service most of the individual test segments and insertions today. So the industry actually, in our, a lot of this, our experience working with a lot of the industry today, what we find out is that the industry, lots of these, the semiconductor manufacturer, they were able to do, what we so-called is a little data. For example, optimizing a specific test insertion, doing analytics like optimizing the yield for wafer sort, stuff like that. However, the billion question, right, it becomes that with the availability of the AI, right, and the computing and the processing, as well as the advanced algorithm, what can the semiconductor industry do with the big data? And that's actually the question we are answering, with a lot of our customer and the supply chain partners. Well, I'll walk through 3 use cases in the next couple slides there, and talk about those, easily add up to more than $1 billion impact to the overall manufacturing and the testing efficiency. And basically that just a heads up, those 3 use cases are just one of the 1,000 use cases actually, that we are working with many of our the customers and ecosystem partners, and there are more to come. And also just want to note here, those savings are just calculated based on from the yield and cost saving perspective. There are actually a lot more factors that push value much higher. And also the $1 billion savings are actually we are calculated based on today's dollars and the volume we see. The impact actually will grow as the industry grows. So the first use cases I like to share with everyone is that talking about how do we optimize the entire test supply chain. As a previous stated there, we've been doing pretty good at optimizing the individual insertions, and often see those insertions are managed independently and are also, geographically in different parts of the world, right? For example, different OSATs, foundry, and also the fabless, they are located in different parts of the world. But what if we can look at that, all those, the supply chain holistically, and apply AI and the machine learning to semiconductor big data across different stages there? We could have actually, fully connected and using the integrated workflow, where machine learning can help us to rebalance our test budget to maximize the entire value, rather than just focusing on insertion-specific optimization. Machine learning can actually dynamically adjust the testing limits at each of the insertion to maximize that value. So in this particular case here, you can see that the machine learning is making a recommendation to fail some die earlier and fail some package chip earlier. And as everybody knows that the cost of those script, right? I think in the early stage, right? I think in the die or the wafer form is actually a lot cheaper in the later stage where you package into a package, or even in the final test or the system level test stage, right? So they actually give a overall cost saving from the both the manufacturing efficiency perspective. So in a nutshell, right, if you look at this case here, machine learning, right, can determine that the die or package will likely fail later in the process, then fail it not, right, and fail earlier. I think that's the one of the key points. And actually, the opposite is also true. If the machine learning can determine that it's actually likely to pass, then skip it to the front of the line, and actually both can providing the net positive outcomes from the manufacturing efficiency and overall cost saving perspective. And in this particular example here, we are assuming 1% in the system level test improvement. In the table, we are using making assumption this is 10 million units per month for the cell phone, the mobile processors here. So the second the use cases here I want to share is actually an example. Want to talk about that how can we actually leveraging the machine learning and to helping on the to sort the die or devices or the wafers into different groups and then determine the complex relationship much more easily and quickly than actually a team of the the engineers, right, the experts that in the semiconductor manufacturers they can do. So in this particular case, the machine learning is being used to examine the data and recommend various level of performance as well as the risks, where the manufacturer they can use to their advantage. By doing so, the silicon can actually be sorted, right, and sold to the right application for the right market, which improve the margins and improve the quality as well. As actually, I mean, as of today, our industry is doing some of this, right, to a certain degree, but with the fully connected system and the feeding the data forward and the backwards throughout the semiconductor supply chain to where it needed, we can actually accomplish the die sorting, right, a lot more efficiently. So I think in this particular case, we're working with some of our the ecosystem partners and the customers out there. We are seeing that the benefit is that instead of taking weeks or days to accomplish the same thing, right? I think usually we can through those the integrated workflow, we can get those done with a matter of hours. So in this particular use cases here, right, we are talking about just to highlight the one aspect of the value, right? That is being able to sell the failed devices into I mean, we can call it the tier 2 or some of the tier 3 market segments. The next, but not the least, the use cases I want to share with Tim is actually one of the holy grails of the in the industry, right? And specifically that how can we leverage the AI machine learning techniques to determine the possible root cause for failures in real time, and also how do we make some recommendation, right, to fix some of the those issues identified. And the value actually of this particular use cases is pretty high because of the high cost of delivering low quality, to a customer. I mean, for example, I mean, no one want to see that their product fail on arrival, right, and having troubles. I mean, this is actually going to be detrimental, not just to the brand but also to the company image. So manufacturers often, when they see issues right in their silicon, typically, it could easily take weeks, if not months, try to determine the root cause, right? I mean, whether that's in the design phase or in certain manufacturing or the test cycles, right? So imagine that with this fully connected workflow we show in the slide here, right? I think using the AI and the machine learning, we can correlate the possible failure mechanism across the the manufacturing and the test life cycle. and providing this, the resolution. A good analogy actually is that you can think about how we do this is that just like everybody, using your GPS on your car, right? I think when the GPS sees there's a traffic or there's a traffic coming, it would automatically reroute you to the better routes. And the financial market actually is using some AI techniques, right? Try to do the risk mitigation in there as a part of the risk, mitigation strategy. So from the semiconductor testing perspective, the machine learning determine whether there's gonna be a system level test failure, and they recommend a series of additional tests at the wafer sort or at the final test, and screen the defect parts earlier in the early stage. And because everything is connected across this, the test supply chain, the system can actually implement the changes automatically live and issue a report to optimize the test flow and significantly reduce the manufacturing cost. So we've seen some of the some good examples, right? Which is showing a huge values, right? I think to improve the manufacturing efficiency and improving the overall the test cost, right? So what can we do from here, right? I think the important things is that today, right? We are seeing that there's lots of the isolated optimization at the each insertion point, and with a lot of this point solution, right? I think the important things is that how can we enable the fully connected system, right? Vertically and horizontally across the silicon manufacturing life cycle. In the next couple of slides, I'll talk about how can we actually get this done and what is needed, right? I think so. The step one is that we have to get to the vertical integration in place, right? So when we talk about the vertical integration, there are thousands of the systems servicing the industry. But from the test cell, the management perspective, right? I think that you are talking about there's lots of the data, right? Including that the semiconductor fabrication process can collect, right, from the tester, from the handler, and there's a lot of sensor from the equipment, from the environment, as well as some the data from the low boards socket, right? So all those data has to be vertically integrated, and we need the ability also need to be able to process the data and being able to make some decision at the edge. So how do we do that, right? I think the solutions that the Advantest, the cloud solution recently introduced, we call it ACSH. It's actually a high performance computer solution with the capability to deliver machine learning and analytics capability, enable the real-time adaptive capability during the production kind of process. The ACSH enable true adaptive test, allowing the real-time adjustment to the production flow and limits, and with the different use cases available from the open solution ecosystem partners. We are seeing that the ACSH actually is helping the semiconductor manufacturers to improve the yield, quality, and reducing cost. We're in the process deploying these production-based ACSH systems, today as we speak, and we also in the process to enable many of the use cases like what we described previously. So the next page here, just briefly talking about the ACSH. I'm not going to go through too much of the details here, but pretty much here we are talking about ACSH is a real-time secure cloud-connected testing cell compute solution enable high-performance compute for rapid test decision making, which is allow the true real-time adaptive test flows, enable the phase secure connectivity between those testing equipments, and improving the OEE, and providing those scalable and portable application deployment through the containers. So we talk about how to do this from the vertical integration. From the horizontal perspective, right? That's actually the step 2, and actually also a very important step, right, to achieve the vision where we talk about how do we connect the data streams, right? Both the forward and the backward across the test and the manufacturing value supply chain. So the horizontal here we talk about specifically is that how do we connecting those data from design, right? From the design house, the fabrics, right, to the fab, to the all the the manufacturing, the offsets, and where there's lots of the manufacturing and the test insertion, and a lot of this infrastructure already today, and how can we go through using this partnership and connect the building the right infrastructure to connect the ecosystem and the supply chain together. So what's pretty interesting here is that we can feed forward of the design, test, and the parametric and the performance data, right? And we can also do this all the way into the front end of the fabs and even into the chip design. For example, feed forward of the parametric test, diagnostic, and in-field data, and with all those, we can identify actionable insights through the silicon life cycle and deliver better yield improvement and reducing the root cause for the wafer yield loss, and also the equipment downtime. And many times we also see that with those integrated data we collected and with the advanced analytics capability, we are seeing that it's not just also improving the yield, but also improving the capacity and efficiency from the OEE perspective. So at the summary here, I want to share that the Advantest Cloud Solutions, our vision is to realize this fully connected ecosystem. It is important that we are building a open solution kind of ecosystem. We are working with the partners like a Portentix, PDF solutions, as well as Synopsys and many other ecosystem partners, and building the solutions and applications running on top of the data. And as you can see in these slides here, right, on top of the in the bottom, all those through all those different stages of the semiconductor, testing and the manufacturing equipment, the ACSH is building the so-called data superhighway, right? And from the data superhighway, we are collecting those real-time data and providing those the data the database, and enable the data warehousing and make it available for not just the customer, but also the third-party ecosystem partners to be able to continue to innovate, right? And providing those different analytic solution and applying a lot of those machine learning algorithm to be able to analyze those big data. So in the end, that it is our vision that we are providing that environment enable the customers and the manufacturer can innovate together and being able to solve a lot more nowadays there's a shortage problem by having the yield and the manufacturing efficiency. So with that, I would like to conclude my presentations. So if there's any questions, feel free to ask. Yeah.
Well, thank you, Michael. That was amazing. I mean, from a traditional wafer probe, final test, to this, what your group is doing, so a lot of that is about bringing data science into this fairly, traditional technology area. That's just, very, very inspiring. And you talk about the ecosystem. As you and I chatted a couple of weeks ago, my company is really a startup called Proteontex. We are hopefully we can work together, right? I mean, we put those agents during the design stage to provide visibility, so that we can detect degradations before degradations turn to expensive failures. With a little bit of time we have, do you have other, examples that, you mentioned the PDF and a couple others. Do you have other, partnership examples you can inspire us, as part of your ecosystem?
Yeah, absolutely. I think, other than the Proteontex, PDF, we are working with many ecosystem partners like the Synopsys, and then there are many more partners that actually we're gonna be announced, in the pipeline. I think the key point here is that I think everybody knows that the AI machine learning are fairly popular in the other vertical industry like healthcare, financial, many other industries. I think in the semiconductor, manufacturing, especially from the testing perspective, we feels like we have a lot of opportunity that together, right? I think with the right application and with the right infrastructure, right, we can build that the data infrastructure, and based on that, I think the important thing is that with this the open solution ecosystem, right? Advantest from the testing infrastructure perspective is able to provide those data infrastructure and enable a lot more innovation, and work with those partners. So I think the beauty is that moving forward, right? I think our vision is similar to like Apple, right? Apple is providing a leading smartphone hardware, and also enable the ecosystem, the partner developing the application, right, to continue to provide the the cost saving, the yield improvement, as well as the overall efficiency. I think that's the vision that we are definitely excited, and we move forward to work with the industry to make this vision happen. Yeah.
Great. So your group is the Apple and iPhone of the test equipment business. Very good.
Yeah.
Okay, so